Alright, chapter 10, number 26. Here's our polar equation. We're trying to find the tangent lines where it crosses the x-axis. So where does it cross the x-axis? That's true when y is equal to 0. So y is equal to r sine theta. So y is equal to 1 plus sine theta times sine theta, because that's what r is. Set that equal to 0. It's already factored, so we can set each of those equal to 0. Sine is 0 at 0 and pi. I assume we're going from 0 to 2 pi. So from 0 to 2 pi. So here's 1 plus sine theta equals 0, so sine theta equals -1, so theta equals 3 pi over 2. So there's 3 times when the curve crosses the x-axis. So we need to know the equation line tangent to the curve at those points. So we need to know the derivative. So we need to know dy dx, which is equal to dy d theta over dx d theta. Well, we already have y, it's right here. We can find x, that is equal to r cosine theta. So x equals 1 plus sine theta cosine theta. So dy d theta, derivative of this, which is, I'll do a product rule, so 1 plus sine theta times the derivative of sine theta, which is cosine theta, plus sine theta times the derivative of 1 plus sine theta, which is cosine theta. So if I distribute, I get cosine theta plus sine theta cosine theta plus sine theta cosine theta. Alright, I guess I could pull a cosine out of everything. 1 plus 2 sine theta. There's my dy d theta. I guess if I distributed, I don't know. I keep changing my mind, so if I have 2 sine theta cosine theta, I can actually make that sine of 2 theta, double angle, so plus sine of 2 theta. That might be the best version of dy d theta. dx d theta, right here another product rule, so 1 plus sine theta times the derivative, which is negative sine theta, plus cosine theta times the derivative, which is cosine theta. So distributing, I have negative sine theta minus sine squared theta plus cosine squared theta. While cosine squared theta minus sine squared theta, that's actually cosine of 2 theta. So that's probably the best dx d theta I can come up with. Alright, so if we want to find dy dx, we do dy d theta over dx d theta. So dy dx, which will give us our slope, equals cosine theta plus sine of 2 theta over cosine of 2 theta minus sine of theta. So we can find our slope. Dy dx at theta equals 0. Dy dx at theta equals pi, and dy dx at theta equals 3 pi over 2. So what's the slope? If I plug in theta, or 0 for theta here, I get cosine of 0, which is 1, plus 0, so we get 1 over cosine of 0, 1 minus 0, so 1 over 1, so we have a slope of 1. Alright, so at theta equals 0, the slope is 1. What's the ordered pair? We could put 0 into our original x's and y's here. If I plug 0 in here, I get 1 plus 0 times 1, so 1 times 1 is 1. So it's an ordered pair of 1, comma. If I plug 0 in here, so now it's just an algebra problem where I have the slope of 1 that goes through 1, 0. Slope 1 goes through 1, 0. So b is negative 1, so y equals 1x minus 1. So there's one tangent line at theta equals 0. At theta equals pi, we can find our slope by plugging it into our derivative. Cosine of pi, negative 1 plus 0, so it's negative 1 over cosine 2 pi is 1 minus 0, so it's negative 1 over 1, which is negative 1. We need to know the ordered pair. Theta equals pi, so I can plug it into x and y. So I get negative 1 times 1, so that's negative 1, comma. Plug in pi here, I get 0. Equation of line, tangent at negative 1, 0. I know the slope is negative 1. So b is negative 1. So y equals negative 1x minus 1. There's my other tangent line. The last one, theta equals pi, 3 pi over 2. Plug it into the derivative, I get 0 plus 0 over cosine of 3 pi, negative 1 minus negative 1, so negative 1 plus 1. Negative 1 plus 1 is 0, so 0 over 0. Great. So we don't know what the slope is there. So we will have to find the limit of our derivative. Time for another page. So the limit of cosine theta plus sine of 2 theta over cosine of 2 theta minus sine theta. That's our derivative, dy dx. And we're finding the limit as theta goes to 3 pi over 2. We already know it's 0 over 0 right now, so we'll use L'Hopital's. Derivative of the top is negative sine theta. Derivative, or plus 2 cosine of 2 theta over derivative cosine is negative 2 sine of 2 theta minus cosine of theta. Hopefully that's enough to figure out what the slope is at that point. Plugging in 3 pi over 2, so sine of 3 pi over 2 is negative 1, opposite of negative 1 is 1, plus 2 times the cosine of 2 times 3 pi over 2, which means cosine of 3 pi, which is negative 1. Let's see, sine of 3 pi is 0, minus cosine of 3 pi over 2 is 0. So I get negative 1 over 0, which is a vertical. So it's going to be x equals whatever the x value is at that point if I wanted to find the tangent line. So let's find the ordered pair by plugging 3 pi over 2 into both our x and y equation. So I get 0 and I get negative 1 times 0. So 0, 0. So at 0, 0, we have a vertical tangent, so x equals 0 would be the tangent line at that point.